Welcome back, everyone. I'm going to go over surface area and volume here quite quickly. We've done surface area and volume in the past, so shouldn't need a lot of explanation. I've cut the cylinder, sphere, and circle off of the EQAO formula sheet. You can always refer to it, and it will be included on your exam, so you don't have any, or at least any formulas you need will be on the exam, so you don't need to have them memorized. Just a quick explanation of sort of what you see on your sheet. I don't know if I have it open here. When you look at the basic sheet, it tells you, it gives you cylinder, surface area, volume all together. And in the surface area, they kind of break down how they get to the final formula. Of course, what you need really is just the final formula. This 2 pi at the end here. This part here is really all you need to make use of. But what they've done is they've broken down that the area of the base, or the top or bottom, is just the area of a circle. Of course, you'll see that the formula is the same as the area of a circle over there. The sides have a height, and then if you rolled this out, give me a second. Okay, so if you bring up a cylinder broken into pieces, this is what you actually have. A rectangle in the middle that's kind of been unfolded, and that's where this idea of the lateral surface comes from. 2 pi r is the circumference of the circle, so it would actually be the width of your rectangle. The height is h, and of course, adding them together to the top, the bottom, there's 2 of the areas of the base, and then the area of the sides as well. But again, in the end, all you really need to know is that the formula at the end is the one that you're using. They just break it down for you so that you can see it. Okay, so area is 2 pi r squared plus 2 pi r h. Now the one big thing with the surface area I've called here the painted area. So if you are kind of painting the outside of the object, this is the area that you're looking at. The one difference between surface area and volume is when pieces are combined, when surfaces are combined, part of the surface has been covered up. So I've got down here, now the sizes aren't the same, but if I took a half a sphere and put it on top of an existing cylinder, what you can hopefully see is that the blue surface of the bottom of the sphere here, bottom of the half sphere, sorry, is covering up the surface of the cylinder. So when you use, or if you are to use this formula as written, you've calculated like there's a bottom to paint, a top to paint, as well as the sides. And in fact, obviously that's not true now because the top has been covered up and doesn't really, or isn't available for us to paint. So you want to recognize that when 2 objects are combined this way, that if the surfaces touch each other, they cover one another up, and the exact formula that you've got may have to be modified. So in this case, I've got this formula, which I can still use as long as I recognize that I've lost the area of the circle over here that's been covered up. And so I can use this formula for the basic surface area of the cylinder, subtract the area of the circle from the top that's been covered up, and then of course I've got half of a sphere here to cover as well. Area of a sphere over here is 4 pi r squared, so what I've got actually is 2 pi r squared, or 4 pi r squared divided by 2. When we look at volume, so if we look at volume now, that's the same is not true. So volume is storage space. So if we have a cylinder again, and the classic half of a sphere goes on top, the fact that the sphere has been put on top of the cylinder doesn't affect the amount of space that the cylinder takes up at all. So if I've got a volume of pi r squared h for the volume of the cylinder, it doesn't actually, it's not affected by the fact that the half sphere has been put on. So in this case, that formula works just fine for the cylinder part of the whole diagram. And then of course, again, I have half of a sphere. These are the volume of a sphere. and hopefully you recognize that those two formulas are identical. Whether I divide 4 by 3 and then multiply by these other values, or I multiply and then divide, I do get the same thing. That comes down, that's that Bedmus idea of division and multiplication being done at the same time. Sorry, tangent there. I can use one of those volumes, cut it in half to get the volume of this the sphere part here, and the two volumes can just be added together. Okay, so this volume is perfectly all right in this case because the sphere being added, or the half sphere being added, does not affect the volume at all. Over here, surface areas are actually being covered up, and so they have to be, that has to be taken into consideration. And the area of the top must be subtracted. That's all I wanted to go over there. Again, both surface area and volume are things you've dealt with before, but just some key ideas there that surface area is being covered up, volume's not affected when two objects are combined.